I've been to the zoo. In 1971, I started work at IP Sharp Associates. This was, as it says here, was a high-tech company before the word high-tech was invented. It's an amazing place, intelligent, thoughtful, kind and gentle, forward-thinking people. And I've been fortunate to work with those folks. So I'm going to talk about what happened. But first of all, I'm going to show you the picture of how I came to work at IP Sharp. I'm going to be quick. I did this talk to myself before I left home, and it took 35 minutes. Well, I've got 30 minutes. So I've got to, I'm going to have to crank through here a bit, so we'll hold questions. 1970, I moved to Toronto from Buffalo. I went to work for a place called Douglas Aircraft of Canada. It was one of those horrible, huge, multi-thousand people things where you shall come to work at 8 in the morning, thou shalt wear a suit and tie, and awful. So I figured, well, this will be great because I'll be working with people who are doing aircraft design and all this. And no, that was all in California. So there I was writing Cobalt programs, doing bean counting in the basement. And it was like Mordor. It was horrible. We had Precambrian hardware. And by this I mean there were two computers. They had a 360 Model 30, which had about as many brains as a squid. It had 8K of memory. It had an emulator for a lovely older machine called a 1401. The emulator, when it was running, nothing else was running on the machine. So it would be, I think I'll read a card now. Okay, I'll print something on this. And then, your basic reader printer stuff. It didn't have a console on it. It had one tape drive and one tape controller. So how do you copy a tape to another tape? Well, you don't. So this was interesting. Well, they had another machine. This was a huge Model 30. It had 32K of memory. It had an even slower card reader. It did not have a printer at all. It also had no console. It had multiple tape drives. It had this huge bank of disk drives. I mean, there were 8 drives, and they were like 29 megabytes each. And it only took about, the rest of the stage to store that much information. I mean, massive database here. So this was a weird setup in many ways. As I said, there's no console. So interactions with the so-called operating system of the day were done by, you'd hit stop on the machine, you'd patch memory, you'd start it up, and you'd poke it to give it an interrupt, and something would happen. And it took forever to do anything. They had 2 tape controllers when they could have used one and shared it between the machines. The bigger machine that was doing all the real grunt work of the bean counting didn't have a printer on it. So they would write output for each job to tape, and each job would have its own tape, and the operator would go and do pokey stuff. And it took forever. So they'd write a separate reel of tape for every job, and they'd be stacked up here and there, and the little union computer operator would go and very carefully label all these things. And I'm trying to get so I'm trying to do a compile and get my syntax error back so I can go back and do it again, and it would take days. This didn't seem to bother anybody. They were going, "Yeah, fine. What's the problem? I can have more coffee." Well, I was going nuts. So mental health was absent, and so I said, "Well, what can I do here?" So I talked to my boss and I said, "Look, if we double the memory on that big machine, then we can run DOS Power," which was it was a print spooling system. It would have let us put the data, or put all the printer output on disk, and then while it's running another job, then we could be printing it. So it immediately let us eliminate all this tape printer, the tape output problem. We concurrently reading stuff for another job. Well, we print another job, and it executes a third job. And I also had, in an earlier incarnation, I'd created a 1401 simulator that would run under this DOS operating system, different flavor of DOS before Gates stole the name. And I said, well, if we did that, then we could run these 1401 jobs without having to dedicate the machine to it. And so I figured, that's a good idea. So we wouldn't need the dinky machine at all. And my boss thought this was a great idea. He said, okay, well, let's do it. We got to get some more memory and a console, but this other machine wouldn't need it. My boss's boss didn't like it, and I didn't twig to the weird hardware configuration. I didn't twig to the fact that the boss's boss didn't like it. But the boss's boss really, really didn't like it. and, you know, of course, I'm a computer junkie. I didn't get the big picture. So somewhere along the line, the boss's boss comes by, heard about this, and he approved the idea. And you know, I went out and did some work at the IBM Test Center, and said, look, it works. And we did it all, and it was magnificent. Turnaround time dropped from days to minutes. We didn't need the dinky machine. We didn't need that extra tape controller. We didn't need a couple extra tape drives. We didn't need one of the card readers. We were able to drop the cost of all the mainframe-related hardware costs went in half. So I had basically paid my entire year's salary every month on this. And they were also able to move some of the computer operators who were busy labeling tapes and things, put them on useful work. And so I figured, well, this is pretty good. So, did I get a big raise? Okay, so this is the picture. The lesson here is look at the big picture. The boss's boss was getting kickbacks from the IBM salesman. So that explained the weird hardware budget. But by then it was a bit late, so off to see the headhunter. This headhunter did more for me than any other single person, I think, in my life, because I talked to him and I said, okay, I want to work on compilers. I said, I want to work my own hours. I don't want to have to wear a suit, and I don't care what it pays. What's he say? There's only one place in town like that. So I had an interview with Ian Sharp, and we talked, and Ian is this lovely Irish guy with an impish sense of humor, a glorious insight on humanity, a wonderful, wonderful guy. And so we said, I want to work in compilers. Yeah, okay. Hours, no problem. Suit, no problem. Pay 20% less. So I got all my wishes. And he said, but you'll have to talk with Roger. And it was like, saying, well, you got to interview with Darth Vader or something. So I had an interview with Roger Moore, and I went across to 74 Vic, where another building, a few blocks away, where our data center was located. And the fade in, you see the noisy room, there's this 2741 hard copy APL terminal banging away, logging things. A 360 Model 50, it was massive, it was huge, hugest machine I'd ever seen. It had 384K of memory, and it was running Sharp APL, and the user load would peak somewhere between 25 to 35 people. A lovely woman named Jackie Selgren, magnificent woman to work with. She was the first commercial operator of an APL system. This was another thing that Sharp did, that Ian had no recognition of the sex of any of his employees in the sense of who's going to do what. It was just, you can do this? Okay, go do it. So, large number of women in high positions at the company, and doing all, you name it, it was all done by anybody. So, definitely a forward-thinking company in that regard. Well, Jackie points me at Roger Moore, and I go, there's this guy, little elfin-type character sitting at a desk, and Roger's there, and he's looking a little rumpled, so that hasn't changed. He's smoking a cigarette, that has changed, and he's staring at this listing and muttering at it, and he keeps muttering. And so, I interrupted him and said that Ian had sent me over to talk about this compiler job because I was going to be working for Roger. And he goes, oh, okay. And he goes back, mutters some more, stares at his bug some more. And after about a minute or two, I realized he's not going to interview me. So I said, well, what are you doing? He said, oh, well, I got this problem here. So we talk about the bug. And this went on for about, 45 minutes or an hour. And finally it was like, I've got another interview scheduled. He says, oh, okay. Well, yeah, I guess we'll hire you. Yeah, okay, Phil. So we were doing in the final throes of the IPSA COBOL project. Now, having already written this APL system, we had to do something else to make money. So they created a COBOL compiler that was really good. But I didn't have a job to do. I came in, they said, okay, you sit there. And I sat there, and after a couple of days, I was like, nobody's going to tell me what to do here. I said, Roger, can I help? And he says, okay, why don't you brown thumb the COBOL compiler? And this was a really good compiler. I mean, it would compile in 10 seconds what the IBM compiler would do in half an hour. The diagnostics were superb. Instead of getting a stack of paper like this, because you try to write to a closed file, it'd say, attempt to write closed file, that one. But I got put to work trying to break the data conversion algorithms. And as I mentioned yesterday, COBOL has 1,000,002 types of data types in it. And you can convert from any of them to any of them. So it's the square of these. So there were umpty-thumb 2 million of these that I had to look at. And so I tried to get a feel for it by hand coding some unit tests on this. And it became really clear relatively quickly that I would probably have to have the help of a computer. So I talked to Roger about it, and he said, well, why don't you use APL to generate the unit tests and check the results? And I didn't know what an APL was, so he says, well, Doug Forks, who was working in the group, he said, why don't you get Doug to teach you some APL? Said, okay, so Doug sits me down at a terminal, looks at me expectantly, does iota 5. He hits enter, and it goes boink. And he sits back and has a smug... So there, and I go, I didn't get it, I said, I got to write a program to do that. He said, I just did. It took a while. So eventually I realized this wasn't not just a one-trick pony. You could do compositions and do fancier stuff. It was just a pocket calculator. So I learned APL, wrote stuff to build these, generate unit tests and run them and analyze it. But the analysis code that I was using to look at this output, it was taking forever. And every time I'd hit break to see where it was, or attention in this case, there's always this caret pointing, where I got stuck. It was always stuck at this X iota Y. And so, again, I talked to Roger, and he said, well, maybe the index of algorithms not very well optimized, or not optimized at all. So he and I sat down, we dug out the interpreter source code, and yes, indeed, we found that it wasn't very optimized. And he said, well, fix it. So at that point in time, I became an APL implementer, and I've been stuck in that job since then. So I did, and I wrote mostly linear time algorithms to do a lot of this stuff. And that became, a couple years later, there was the APL Congress in Copenhagen, and that's where I did my first knees-knocking professional talk and my first paper. And as you can see, we were ahead of the curve. This was computer typeset. And I had no trouble with the APL font because I was using the APL typeball. Now, of course, it was the only font I had. So it was all uppercase. You go down the street from Copenhagen, and you find the IP Sharp Intersystems office at 244 Hengracht in Amsterdam. And this was a magnificent place. My office, our offices were on the basement, the first floor, and I was staying up here. I had the whole top floor to myself. It was lovely, and I'd get up in the morning, I'd make myself a coffee, I'd open these huge windows, I'd sit on the thing and look at, the beautiful Dutch women riding back and forth on their bicycles and the ships going by and the trucks, and it was magnificent. When I got tired of that, I'd go downstairs and I'd be at work. Well, this is okay, I can handle this. The Amsterdam office was an amazing place. There was so much stuff going on there. Michael Harbinson put together did the first cut at IPSA. We had it was a package switching system that predated the internet and made it possible for us to make a worldwide, reliable, high-performance network. That was mostly Harbinson's early design. Another group at InterSystems, which was the official name of this joint, us, but not me. We wrote the Schiphol air traffic control system. So Sharp was doing, there's a whole lot of stuff going on there. And then me and half a dozen other people migrated in out of that office, working on the Siemens BS2000, APL system, which is a lot of fun. I spent several months in Amsterdam, fell in love with the place. And so there's good stuff. We worked on a lot of APLs. You'll see some more of them come along. We hop up to 1978, and hardware is getting fast. We were running a large time-sharing system, and APL had its old 1960s style tri-centisecond timers. So you could only bill CPU time, which was how we were paying the rent. You could only do that to an accuracy of a 300th of a second. And what would happen, of course, is this guy over here would do a matrix divide, and it would run for almost a 300th of a second, but the clock wouldn't tick, so he'd get billed 0. You'd come along, you type iota 5, and the clock would tick, and you'd get billed the whole thing. So we had to fix this, and the trigger for this was a new Amdahl machine we put in there. I think it was a V6-2, and it had a much bigger cache, and that led to other problems. So anyway, in the course of this, I redesigned all the timers in Sharp APL to use these 64-bit high precision timers that were introduced with the System 370. It was a very elegant, powerful, very clean design that none of the Intel people or anybody else since has seen. At the same time this was going on, I was doing the implementation, also in assembler code, just like Bob, of enclosed arrays for Sharp APL. And in the course of doing this, as Bob mentioned, when you put in a new data type, you get to put your hands or your feet on every primitive in the system. So I looked at reverse and rotate, and I said, oh man, are those ever ugly? So I fixed them, and I made them. So I wrote nice, what I consider high-performance algorithms, and my ego was needing some help then, so I said, okay, I'm going to compare the old and the new. And I did that, and I got this. And so these were the old timings. This is timing going up this axis and array size going over here. And these are different data types, Boolean, integer, floating character. And these are my new algorithms. Oh, nice, shiny, way, way faster. And I said, well, okay, but what's this? What's all this jitter? What's all this spiky stuff? And what are these spikes down here? And I couldn't figure out why my shiny new stuff was getting so few of these spikes compared to the other one until I saw, oh, if that was up there, all those spikes would be much closer together. So they're the same phenomenon. And so I said, well, that's interesting. And so I said, let's zoom in on it. And I realized these spikes were hugely expensive. I mean, so the spike was enough time to do a reverse of a 10,000 element vector. I said, well, that's wrong. And I poked around and took things apart. And one of the things we had in Sharp APL, we had many concurrent users. And the way that we kept a corruption in the interpreter from taking the whole system down was we used memory protection and gave each user memory slot their own key of memory. And that way, a bug in the interpreter would only blow away that one user, and they couldn't corrupt the operating system or the interpreter or other people's stuff. And the key was something called set storage key, which would set a given piece of memory to a given key. So I traced the spikes down to that, and I said, okay, well, what happens if I disable them? Well, if I disable them, all of a sudden, spikes went away, everything's beautiful. So it turned out our new AMDL V8, it had these huge cache. And I looked, this was still back in the dark ages when they still published instruction timings. I looked, and the set storage key instruction was a lot slower. And it was actually worse than that. I ended up meeting with Gene Amdahl, the designer of those machines, and we talked about it for a while. And once he saw what was going on, he was like, oh. It's one of those, oh, gee, look at that. Okay, well, too bad. I understand the problem, but it's not going to get fixed in this generation of machines. So we had to go and find something else. So what we became clear the architecture wasn't going to change, so we gave each workspace key its own, or each workspace slot its own key at startup. And this more or less worked, but there was only a few keys available, so we sort of interleaved them, so the chances of you corrupting another workspace were low. But so system integrity was slightly reduced, but the problem went away, and so did the complaints about CPU billing. I'm going to look back at what was happening. I'll just give you a couple of little bits of what was going on at Sharp in the early 70s. When I started there in 1971, we had 666 box. It was an email before the internet. That was written by Larry Breed, and 666 box, it was highly secure, and it had an interesting thing that most new email systems don't have. You could withdraw a message. So when you do one of those send, oh shit. Can't do that anymore. A bunch of us were working on an APL system for the control data star 100 supercomputer, memory-to-memory supercomputer they were building in Mississauga, just outside Toronto. I didn't work on this project. I wish I did, because big iron always makes you feel better. But I was on the fringe of this. I know some of the people who were working on it, but the work was all being done by these other guys. And the star inner product algorithm that I talked about yesterday derives from stuff they did because they needed a Stride 1 cache-friendly implementation for that machine, or it just wouldn't work at all. So they came up with that algorithm for normal matrix products. I adapted it for the Boolean stuff that you saw, and it's also, I use it in the Apex compiler and other things. So this is going on. I said that at the same time, a bunch of us were working on an APL interpreter for Siemens. Somewhere along the line here, this was Larry Breed was by then had left IBM. He was working for what was then Scientific Timesharing, now called Manugistics, now called APL 2000, and so on. We were sharing development work with them. And we were using the Toronto machine as the main data center. That worked for quite a while until the load got big enough and the politics got worse enough that they went their own way and we went ours. Well, Larry Breed was was in Toronto when I was when I started, and fairly soon. I don't remember the exact year, but it would have been probably 71, 72. Larry Breed came up and designed and implemented this APL scalar function compiler. So it was a JIT, an early JIT experiment. And of course, the rest of us, people in the development group, all copied his fundamental design idea. And so we JITted everything. It's like, oh, catenate, I can make catenate run fast this way, and so on. So that went on for quite a while. We wrote APL systems for Hitachi and Fujitsu. Much later, ended up working with Dr. Jaffe down here on producing, I wrote a primitive APL compiler called Acorn so they could do large computations on the Cray XMP, YMP. We later ported that to the connection machine, which I think is probably still the most processor-laden computer to have APL running on it ever, 64,000 processors. We outgrew the 74-VIC data center. It was an old building. It didn't have enough power. There was no place for more air conditioning and so on. So we moved to 145 King Street West, next to the TD Center in Toronto. The offices, the business office and sales office moved from the TD Center to 145 King. The data center moved there, and the user load was now up to about 1,000 concurrent users, giving each of these people, 1/10 of a second response time. Not bad. So we had the development group, the data center, on one side of the elevator, one direction from the elevator lobby, sales, marketing, bean counting, and all that on the other side. No security. Hadn't been invented yet. So what happens? Well, some client gets off the elevators, walks the wrong way, and instead of going into the marketing and sales things, walks into the middle of the machine room. Somebody comes and says, oh, what are you doing here? He says, well, I'm looking for so-and-so. Oh, it's over here. Okay, fine. But he's, shocking. There's all these scruffy, bearded, blue-jeaned people. It didn't look like the financial district at all. It's very upset. Well, so this was corrected. The next day, we had new signs appear at the elevator doors. That sort of worked. Now, time marched on again. I want to say, Ian wanted to give people an interesting place to work, and he really did. I'm happy he did so because we all owe him, thanks for his vision and spirit. This is, I think, the last surviving picture I've got of me playing around with the Tinker Toy set. It's an IBM 3084, I think, is the largest mainframe I ever worked on. So we had lots of fun and lots of good people, but the signs in the elevator door were not enough. So another one gets lost, wanders through the wrong part of the office, and he sees these developers, they're not chained to their desk. There's something fundamentally wrong here. He's getting escorted away by the marketeer or the sales guy, and he says, this place is Well, the name stuck, and even under the email address, because the email address for the IP Sharp Development Group was zoo. And so, with apologies to Edward Albee, I can truly say, I've been to the zoo. Thanks.